Hi folks, we're going to take a look at question 10 from page 92 on one of the previous homeworks. So they ask us to determine which pair of lines are parallel and which are perpendicular. So first and foremost, keep in mind that when working with the vector parametric equations of a line, we can use the direction vectors to determine whether two lines are parallel or perpendicular. So essentially, if two lines are parallel, okay, their direction vectors should also be parallel to each other. Whereas if two lines are perpendicular, well, guess what? Okay, if I were to move this direction vector here and I moved this direction vector there, well, those two direction vectors should also be parallel. Okay, so the way in which we show two vectors are parallel is to show that they're scalar multiples of each other, and the way we show that two vectors are perpendicular, of course, is to check whether the dot product is 0. So if we take a look at this first example here, okay, we see that it's given in parametric form. So in A, I have to look for those direction vectors. So the direction vectors are multiplying the parameter t. So in parametric form, the x component of the direction vector would be the number multiplying t in this equation, so -3, and the y component, the one that multiplies t in the equation for y. So -3, 4 would be one direction vector, and then similarly in the other question, or the other line, it would be -4, -3. So let's take a look at these two. So if we look at 10a, I'll just write them down. We have the first direction vector is -3, 4, and then the second direction vector is equal to -4, -3. Okay? So here, clearly they're not scalar multiples of each other, so these two cannot be parallel. But if we take the dot product, let's see if it gives us 0. Okay, so we have -3 times -4, which is +12, plus, and 4 times -3 is -12, and that's equal to 0. Okay, now if you did watch that other video on the trick that we can use to see if two vectors are perpendicular, okay, we can see here that the trick was that a perpendicular vector to -4, 3 can be gotten by, okay, so a perpendicular vector can be gotten by switching the components, okay, and changing the sign. Okay, so and here this -3 would become +3. That would be a perpendicular vector, and of course anything that's parallel to it, so in this case here -4, -3, would also be perpendicular to -3, 4. Okay, so another way in which to determine whether it's parallel or perpendicular. Okay, let's take a look now at B. Okay, sorry about that. If we take a look at B, this is a little easier because they're already given in a vector form. So you just look at the vector that multiplies t, in here -3, 4, the vector that multiplies s in the second equation, 3, -4, and I'm actually not going to write anything down because clearly here these are scalar multiples of each other. Because if I multiply this vector by -1, I'll end up with +3, -4. And so these two lines must be parallel because their direction vectors are parallel, scalar multiples of each other. Okay, so let's take a look at C. And again, quickly we do -3 times 4 is -12, plus 4 times -3, -12. So -12 minus -12 is not equal to 0. So, and clearly they're not scalar multiples of each other. So C is neither parallel nor perpendicular. Okay? So again, when you're trying to determine parallel and perpendicular with lines, okay, the only thing you need to look at is their individual direction vectors. If they're scalar multiples of each other, it means that the lines are parallel, and if the dot product of the direction vectors is equal to 0, it means they're perpendicular. Okay, that's it.